Hey everyone, hope everyone had a nice weekend. We're in February now. So, what was I gonna say? As a reminder, homework will be assigned on Wednesday, actually. I know I was supposed to assign it today, but I felt like I didn't really get far enough to assign homework, so I figured it'd be better to assign it on Wednesday. So homework will be assigned Wednesday. What I will do is have it due the following Tuesday. So you get almost a week to complete it. What I'm probably going to do also is maybe assign like a quiz, a quiz. Again, it will be take home. And you'll have, some time to do it. I'll keep everyone posted about it. But if you still cannot access Lumen Learning, again, the information's in the syllabus. Don't be afraid to contact me, okay? I'm here to help. That's, what I'm here to do, okay? All right, so thinking that, I think that's it. Okay, so I did email the notes. The worksheet I'm hoping to get to, if I don't, I'll just post solutions to it, and I do recommend you try it out on your own. So, all right, let me get to the lectures now. All right, so let me stop sharing this. Okay. All right, so again, these are the notes I sent everyone. Let me just make sure, is this recording? Yes, it is, and everyone can see it. Good. Okay. All right. So here, what I basically want to do is I want to go through some more examples with polynomial addition and subtraction. What I'm going to focus on is adding vertically. I think the book also calls it the column method, if I remember correctly. So that's what I figured we'd do more examples of that, okay? And, again, depending on how far I get, I want to start polynomial multiplication. That is actually treated in a similar way to polynomial addition and subtraction, in that first we'll start with monomials. Then what will happen is we'll get to polynomials, okay? All right. Okay, I do want to post practice questions as well, but the problem is, again, I only have the 3rd edition of the book. I'm still trying to get the 4th edition. So again, I do apologize that I haven't done that yet. I'm working on that. Okay. I could post the problems for the 3rd edition. I don't know how similar they are. So anyway, let me start with this. So again, also, if you want to add polynomials using a different method than I do, that's fine. That's fine. I don't know any other examples between the two I mentioned last time, but if you want to try something else, if you know another method, or you want to use either one of the two, that's fine. All right. So this is our first example. We're going to add these two polynomials together. And again, really it boils down to combining like terms. And what I like about the vertical method, or column method as the book calls it, it's more visual, and it also helps me stay more organized. Okay, so what I like to do is, since we're adding, find the sum, I like to put the polynomial that has more terms on top. And that's what I do here, right? Each term gets its own column. Each term gets its own column. That's what we're doing. And now for the second polynomial, like terms can only go in the same column, right? Like terms go in the same column. So for the 3x squared, that's going to go in this column, right? That's what's going to happen here. The 2x is going to go in here, right? 2x and 4x are like terms, right? To be like terms, they have to be in the same variable, and they have to have the same degree. In other words, they have to have the same exponent. They have to have the same exponent of x, same power of x. 5 is going to be in this column, right? Constant terms. Those are like terms. So we get this. That's all handled. right? We could leave this blank if we wanted to. I like to put a 0 in there. Or in this case, 0 times x cubed. The impression I got was that people prefer if I write this instead of just 0. It just makes it a little bit easier, I guess, to see, you know, the placeholders or whatever. So that's fine. But now we can add, and adding, we get x cubed plus 0 is x cubed. X squared plus 3x squared. Again, you combine coefficients, you get 4x squared. 4x plus 2x, you get 6x. Negative 12 plus 5, that's negative 7. So these are the terms of our answer. But of course, we want to write our answer as a polynomial. Okay, so we do that. And notice it's already in standard form. How do I know that? The exponents of x, they're decreasing as you go from left to right. Okay, so that's good. So that problem is done. Okay, so that's good. Okay, so that's our first example. Okay. Okay, I'm not sure why I had example 2 as the first one there, but that's okay. Let's move on to another one. So here we're going to subtract, right? We're subtracting this polynomial from this one. Okay, in other words, we're going to calculate this. I mean, subtraction is not as nice as addition in that you don't get a choice in what goes on top, so to say, because subtraction is not commutative, meaning the order does make a difference. So this one is going to be the one on top. Okay, and you see, actually, I'm going to explain subtraction here a little bit differently. I'm going to proceed a little bit differently, although it's really the same idea. And I hope it makes sense. But again, you know, we're using the vertical method. So each term, as you can see, is going to get its own column. We're subtracting, so that's over there. So this polynomial is what's going to go below. And right away, you can see this kind of a, I guess, I don't want to say dilemma, but problem. Maybe that's better, right? Because we have x cubed here. Can x cubed go in either of these columns? Well, no, it can't, right? Because x cubed is not a like term with any of these. What do? We make another column, as you can see. And that's what we did here. We made another column, okay, to handle x cubed. Okay, so that's good. What about the minus 8x squared? Well, that can go in this column, right? Because you have minus 8x squared, 2x squared. That goes in this column, so that's good, right? X, right? Now we have another problem, right? X cannot go in any of these columns, right? Because x and any of these terms are unlike terms. So we make another column for x. Right? So sometimes you have to add on columns at the end. I think last time what I was doing, it was the same idea, but I kept putting the columns in between. But if you were writing this out by hand, that can be cumbersome. So that's why I'm putting them on at the end. I mean, the idea is still the same. So we make another column for x. Finally, we have this 5, right? This 5 is going to be in this column, right? It's a column of constants, so to say. They're like terms. Okay, so that's good. So we handled everything. We have these empty spots. Well, we can leave them blank if you want. I like to put zeros in there, and that's what I did. As you can see, we have 0 times x to the 4th, 0x cubed or 0x. Again, you could put 0 in here if you want, instead of what I wrote, but you know, it's really the same thing. Although I think it's more precise to just write 0. But again, for this class, if you write 0x to the 4, 0x cubed, that's fine. Now, are we ready to combine yet? Well, almost. Because with subtraction, you want to distribute the negative. In other words, in the vertical method, this minus is going to become addition, but then we have to distribute a negative to the second polynomial, the one on the bottom. And that's what I did here. Okay, right? Before, again, we have to convert this to addition. We have to distribute the negative. So this will become addition. This will get negated. We have this, right? We had a negative before. So now it becomes a positive. You know, by Sap and Sun rules, two negatives is a positive. This was a positive. Now it's negative. This was positive, and so is this one. Now they're both negated. Finally, we can combine, and what happens? We get this. Okay, yeah.
So basically, when you're subtracting, all the numbers that you that are like terms that were positive just become negative, basically.
In the second row, yeah.
Okay. So that
And
only
then
happens
you,
when you're subtracting polynomials.
exactly, yeah.
Okay.
Okay. Awesome question. And now we have and this becomes addition as well. Okay. So now we just add, we get x to the 4, 10x squared, 5 plus negative 5 is 0, minus x cubed, and minus x. Okay, so those are the terms of our answer, and that's what this is. We're not quite done yet, though, right? Because again, you want to write your answer in standard form, and that's not in standard form, right? You want the exponents of x to decrease as you go from left to right. Does that happen? Well, there's a 3 here. So no, it doesn't. You know, it goes from 2 to 3. Not to mention also we have a 0 here as an intermediate term, so to say. You really don't want to have 0 in there. So we write it in standard form. And that's all I did. Basically, again, I removed this 0 minus x cubed I put over here, as you can see. Okay, that's good.